Hello students, welcome in another session of XII Computer Science Paper 2. Now let us proceed chapter 2 Instruction Set and Programming of 8085 Microprocessor session 23. Student, in this video I am explaining SIM and RIM instructions of 8085 microprocessor. This is also a machine control group instruction. And this is the last instruction in this chapter. So student, only remaining program is remaining and it will take in next session, but theory part are completed. All instructions are now completed. So chapter is completed except programs. Okay. So students, these two instructions are very important related to board exam, because these instructions asked in board exam for 3 marks. So see, let us first instruction, SIM instruction. SIM stands for Set Interrupt Mask. Set Interrupt Mask means, see, format is stored 0. 0 means mask. Addressing no, because in these instructions only set or reset mask or unmask or check whether it is set or status of these interrupts. Only 1 byte is required to store the instruction in memory location. So SIM means Set Interrupt Mask. What do you mean by masking or mask? Mask means avoid. Mask means avoid. It is a multi-purpose instruction. This instruction is multi-purpose instruction or multiple operation. Now what is the purpose or function of these instructions? Means main uses of this instruction. When SIM instruction is executed, then the content of accumulator decide the action to be taken. So before executing the SIM instruction, it is mandatory to initialize accumulator with the required value. Student, these instructions have no format. This is a wrong statement. Okay, so this is deleted. Only 1 byte is required. No addressing mode is there. Don't write format, because this SIM or RIM instructions, some patterns are given. Okay, now see, this is a multi-purpose instruction. Okay, when SIM instruction is executed, then the content of the accumulator decides the action to be taken. So before executing the SIM instruction, it is mandatory to initialize accumulator with the required value. Means, first store the data into the accumulator, then execute the SIM instruction. Because after store the data in accumulator, that data to be decides the which action to be taken. Understood, student? Means, always remember, when SIM or RIM instructions are executed, then first store the data into the accumulator. Now see the main uses of this SIM instruction. Masking or unmasking of RST 7.5, RST 6.5, RST 5.5. Reset RST 7.5 flip-flop. Perform serial output of data. Student, this instruction is used for serially data output. Okay, serially data output. Meaning data, output data can be serially transmitted. When SIM instruction is executed, then the content of the accumulator decide the action to be taken. So before executing the SIM instruction, store the data in accumulator. And now it is mandatory to store the data in accumulator first, then execute SIM instruction. Now students see one by one these main uses of this SIM instruction: masking, unmasking, reset, and perform serial output of data. Masking, unmasking. You know, mask means avoid. Okay. Now see pattern of this SIM instruction. See, this is a D0 to D7. This is a bit status. Now at D0 M5.5, at D1 M6.5, D2 M7.5, D3 MSE, D4 R7.5, D5 XX means don't care, either 1 or either 0, D6 SDE, and D7 SOD. Now student, see, SOD means serial data output or serial output data, means data transfer to the outside. Data transfer to the outside. Outside means any, for example monitor, for example LED. Okay. So data transfer to the outside. Now these SDE pins means serial data enable. Enable means 1 and 0 means disable. Student, in 8085 microprocessor has 2 pins specially designed for serial communication. These 2 pins already we have seen at starting at pin diagram, SOD and SID. These 2 pins are used for this SIM and read instruction. SOD means serial output data and SID means serial input data. So SIM is used for data output. Okay, SIM is used for data output. Serially means single bit at a time. Transfer single bit at a time. Means in 8085 microprocessor, data bus transfer data 1 byte means 8 bit transfer data one location to another location at a time. But in these instructions, when SIM or RIM instruction is used, then one by one, only one single bit can be transferred serially at a time. Okay, this is the difference between SIM instruction and in 8085 totally data can be transferred. Data bus data transfer 1 byte at a time, and here 1 bit at a time. Okay, this is the difference between them. Now SDE means serial data enable. 1 means enable, 0 means disable. If bit D7, see, bit D7 means SOD. D7 is sent to SOD line. SOD line means this pin in pin diagram. Okay, SOD is a pin in pin diagram. When bit D7, data transferred to processor through SOD line. Okay, not directly transfer, through SOD line. If SDE is 1, if serial data enable means this D6 pin is 1, then activate SED pin. Okay, if SDE is 1, then activate SDE pin. If SDE pin is 0, the serial communication is not activated. Understood, student? If in this position, if 1 is there, then activate SDE pin. If here 0 is there, then serial communication is not activated. Means whatever data in SOD, either 0 or 1, that data transfer through SOD to output device. Don't matter 1 or 0, but if SDE is 0, see, if SDE is 0, the serial communication is not activated. Means first two pins, means these SOD and SDE pins are used for serial communication. Understood, student? Means these pins, whatever stored in 1 or 0, don't forget that. But when if 0 is there, then this is unactivate, means can't transfer the data through SOD to output device. But here 1 is there, then activate the SDE pin. Okay, understood, student? Now see one by one what is M5.5, M6.5, M7.5, MSE and R7.5. Okay, now see in detail. See here, this diagram already seen in block diagram in 8085 microprocessor. Okay, this is a small part in between. Okay, so see here, trap, RST 7.5, RST 6.5, RST 5.5, INTR, INTR. Student, what is this? This is a hardware interrupt. This is a hardware interrupt. Now see what is the relation between these interrupts and these M5.5, 6.5, 7.5, 7 and these R7.5. Okay. Now student, trap is a non-maskable interrupt. Trap is a non-maskable interrupt because it is a compulsory. म्हणजे आपण ट्रॅपला अवॉइड करू शकत नाही. When trap is required, when trap is interrupted, then compulsory it can be accepted. Okay, but other interrupts can be blocked, avoid because it is maskable. Understood? Only trap is a non-maskable. Other interrupts are maskable. It may be blocked, it may be avoid, but trap is, we can't be avoid this trap interrupt. This is the difference between this other and trap interrupt. Now see M5.5. What is this M? M means mask. 5.5. Okay, mask RST 5.5. Okay, this is a pins. This is a hardware interrupts. Mask RST 5.5. Now 1 indicates mask, 0 indicates unmasked. If at this position, means at D0 position 1 is there, then it is maskable. Maskable means it is blocked. Okay. Suppose these interrupts sent to the processor, the microprocessor can't accept because we store 1. 1 means mask and mask means block. So microprocessor cannot accept this interrupt. Okay, because at D0 position we store the 1, means it is a maskable, but we don't want to block the interrupt. Suppose we don't want to block the interrupt, then 0 store at D0 position. Then 8085 microprocessor accept interrupts. Understood, student? What is the difference between 1 and 0? If 1 is there, then it is a block. Means 8085 microprocessor can't accept this interrupt. But 0 is there, then 8085 accept the interrupt. Same as M6.5 and M7.5. Same. If 1 is there, then it is a maskable. Means it is a block. If 0 is there, then unmasked, may accept the interrupt. Same as M7.5 means M means mask, RST 7.5. If 1 is there, then maskable means block. This interrupt is block. If 0 is there, then interrupt is accepted in 8085 microprocessor. Now, what is the meaning of this MSE? This is very important bit or very important status of this M7.5, 6.5, 5.5. MSE means mask set enable. What is the long form? Mask set enable. If 1 is there, mask is set. If 1 is there, mask is set. Then what is the use of these pins? See, M7.5, M6.5 and M5.5, these pins are depend on these MSE pins. Okay, these 3 pins are depends on these MSE pins. Means if MSE pins is equal to 1, then these 3 pins, okay, these 3 pins are working accordingly to provide the data. If MSE is 0, then D0, D1 and D2 pins are ignored. Means if you want use these pins, the first set the MSE pins. Means MSE is a global pins. Okay, MSE is a global pins. Why it is called as global pins? Because these 3 pins are depends on these MSE pins. Okay, then see how it is. Means without this pin you can't use these 3 pins. Okay, suppose means if here 1 is there, then it is activated. If MSE pin is 0, then it is unactivated. Means suppose you want to, these 3 pins are activated, means unblock, means M7.5, M6.5, M5.5. Suppose in M5.5 1 is there, okay, M6.5 1 is there and M7.5 1 is there, but MSE here 0 is there, then don't use these 3 pins. Okay, because MSE is 0 position, MSE stored 0, but you want to activate these pins M7.5, M6.5, M5.5, then MSE stored 1. So then D0 to D2 pins are activated. Understood, student? Now next pin is R7.5. R means reset. R means reset. Okay, R7.5 means if RST 7.5 is equal to 1, then it is not allowed, and RST 7.5 is equal to 0, then it is allowed. Okay, means reset 7.5 is a flip flop. Flip means 1, flop means 0, which is inside the 8085 microprocessor. If RST 7.5 1 is there at bit D4 position, it is not allowed, and if it is 0, then it is allowed. For these pins, separate facility is provided in 8085 microprocessor. Understood, student? So, student, in SIM instruction, these two bits SOD and SDE, these 2 pins are used for serial communication. These 3 D0, D1, D2, these 3 pins depends on these MSE pins. If MSE is 1, then activate these 3 pins, and these 3 pins means this is a maskable or unmaskable, means interrupt is block or unblock. Okay, but these 3 pins totally depends on these MSE pins. And what is R? R is means reset 7.5, RST 7.5. If 1 is there, then it is not allowed. If 0 is there, then it is allowed. This is the SIM instruction. Understood, student? How to execute SIM instruction? Now see, next is RIM instruction. In RIM instruction, RIM stands for read interrupt marks, opposite of SIM. Read stands for read interrupt marks. Sorry student, here also don't write any format. Okay. Addressing none. Byte is 1 byte. Only 1 byte is required to store the data in memory location. Now student, in this instruction don't have any operand, because only 1 byte is required, so don't have any operand. Accordingly to user, first data stored in accumulator, then decide mask is block or unblock, or activate the serial communication. Okay, activate the serial communication. Student, this instruction is used for only reading purpose. Only reading purpose. So, purpose of this instruction or function of this instruction, which interrupt is masked or unmasked. In this instruction, we don't make set or reset because only for reading. Inside the microprocessor, which interrupt is masked, which interrupt is pending or not, which interrupt is enabled or disabled. This is the purpose of RIM instruction. Understood, student? Means this instruction is only for check the status of interrupts, whether it is masked or unmasked, whether it is enabled or not, whether it is pending or not. Means RIM instruction is only for check the status of interrupt signal. Now, what is the use of this RIM instruction? First, perform serial input of data. First, purpose of this instruction is receive the data from input device. Input device means maybe keyboard. Okay, maybe keyboard. It is an input device through SID pin. Okay, SOD and SID. SOD is used for SIM instruction. SID is used for RIM instruction. SID, set interrupt input device. Okay, SID pin. Then store that bit in accumulator at bit D7 position. Okay. Now see, second, to check whether RST 7.5, RST 6.5 and RST 5.5 are masked or not. Third use for this instruction is to check whether interrupts are enabled or not. And last one is to check whether RST 7.5, RST 6.5 and RST 5.5 interrupts are pending or not. This is a main uses of this RIM instruction. And one more thing is, student, it is mandatory to initialize accumulator with the required value. Means first store the value in accumulator, then execute this RIM instruction. Now see, first purpose of this instruction is receive the data. Okay, now see, first format of this RIM instruction, D0 to D7, this is the bit position. At D0 M5.5, at D1 M6.5, at D2 M7.5, at D3 IE means interrupt enable, at D4 P5.5, D5 P6.5, D6 P7.5 and D7 SID pin is there. Okay, SID pin is connected to this RIM instruction. Now, first purpose of this RIM instruction or first use of this RIM instruction is receive the data from input device through SID pin. Then store that bit in accumulator. Store that bit in accumulator at D7 position in accumulator. This is an accumulator. Okay, this data stored in accumulator. So, when RIM instruction is used, then first store the data in accumulator at D7 position. SID means serial data input. Now next, whether RST 7.5, RST 6.5, RST 5.5 are masked or not. Means D0, D1 and D2, these pins are checked whether it is masked or not. Okay, whether it is check or masked or not. For before that, see P7.5. P means pending. P means pending. P stands for pending. If one is there, then RST 7.5 interrupt pending. Okay. In 8085 microprocessor, different interrupts are available, but microprocessor accepts only one interrupt at a time. Microprocessor accepts only one interrupt at a time. If at a time 3 interrupts are sending, but microprocessor accepts only one interrupt, then remaining 2 interrupts goes to pending or waiting state. Okay, see, P7.5 if 1 is there, then interrupt is pending. P6.5 if 1 is there, then interrupt is pending, and P5.5 if 1 is there, and then interrupt is pending. Suppose student at D6 position, it indicates pending. Okay, maybe after some time microprocessor accept it, same as D5, same as D4. Now if all 3 pins are 1, then all 3 pins are pending position. Suppose student here, this is 1, this is 0, and this is 1. Means what is the meaning of this 1 0 1? If store here in accumulator 1 bit at D6, 0 bit at D5 and 1 bit at D4. So student, if 1 is there here, then RST 7.5 interrupt pending. If 0 is there, so RST 6.5 are not pending. Okay, and P is there, means RST 5.5 is pending. Means if at a time, suppose only 3 interrupts are sending in microprocessor, microprocessor accept only one, other 2 interrupts may be in pending position, and depends on this 1 or 0 bit position. Understood student? What is P7.5, P6.5 and P5.5? Okay, P means pending. Suppose now see IE. IE means interrupt enable. Already these pins we have seen in previous session. Okay, this pin or this instruction is only for enable the interrupt. It is the status of interrupt enable. E means enable, I means interrupt. Means interrupt is enable or disable, which this status is checked through IE pins. If IE pin is 1, then it indicates interrupt is enable. If IE pin is 0, then interrupt is disable, means reset. Then how to do these pins is enable or disable? In 8085 microprocessor, IE instruction is there. Okay, IE instruction is there, which is already seen in previous video. Through this instruction, make interrupt is enabled or disabled. Now see, M7.5, M6.5 and M7.5.5. These are, M means masking. Okay, M means masking. Mask 5.5, mask 6.5 or mask 7.5. Mask means block. Then what is the, these pins are indicates current masking status of interrupt set by user using SIM instruction. See, in previous instruction 0 is available and 1 is mask. Student, instead of this here, write here 1. Okay, so student, see here, instead of 0 write here 1. Student, mask 5.5, this indicates that the current masking status of interrupt set by user using SIM instruction. If 0 is available and 1 is marked, means in SIM instruction, what is the status of these 3 pins? Which 3 pins? M7.5, M6.5, M5.5. Suppose we want to check its status, then using these 3 pins M7.5, 6.5 and 5.5, check it is masked or not. Understood student? Means for these pins only using for check the status of interrupts, whether it is masked or unmasked. Okay, so student, remember what is the difference between SIM and RIM instruction? SIM instruction used for serial data out or make interrupt is mask or unmask. And rim instruction is used for serial data input or read the data, or which interrupt is masked or not, means check status of interrupts. Okay student, rim is used for reading, sim is used for setting the interrupt, mask or unmask. Understood student? Hope you understand the all instructions in 8085 microprocessor. Student, suppose in exam this instruction ask for explain with example. Then student take any example, suppose in accumulator contain 5FH. Okay, then how to write it? Okay, suppose 5F converted into binary. 5 means 0 1 0 1 and F means 1 1 1 1. Okay, now these bits are put in this bit position, means here 0 1 0 1, here 1 1 1 1. Now write the meaning of this. After put this 5F, write the meaning. 0 means serial data input. This 0 transferred through to receive the data through SID pin. Okay. P 1 means C. If P 7.5 1 is there, okay, 1 is there, so this is a pending position. Here 0 means it is not pending position. Here 1, it is a pending position. Again here 1 means interrupt is enabled. Here 1 1 1 means it is a mask. Okay, like this you can take any example, write any example, you can take any binary numbers, any number for explaining example. Okay, understood student? Sim and rim instruction. Rim is used for reading, sim is used for setting the interrupts, mask or unmask. Okay student, so end of this session 23 and also end of this, or also completed all instruction in this 8085 microprocessor chapter or chapter 2nd, only remaining program. So let us these programs see in next lecture. Okay, thank you student.